Cool. First of all, hope you're having a great time, and big thanks to Tanisha and Souvik for such a great insightful talk. So mine is going to be a very short talk about building offline first React applications with RxDB and Hasura. So firstly, I am Rishi. I work in the engineering team at Hasura. I mainly work on React and Node.js, and since we are a GraphQL-centered company, we all work on GraphQL all the time. So if you want to know more about me, you can go to my personal homepage. You'll find my social handles there itself. So coming to the talk, recently at Hasura, we've been exploring a lot of different approaches and architectures. At Hasura recently, we've been looking at a lot of different approaches and architectures of building applications, and a lot of different patterns and paradigms of building applications. And very recently, we've been playing around with and exploring the offline first architecture. And that's sort of what I'll be sharing with you all today. So building offline first apps with RxDB and Hasura. There are a bunch of new words here, offline first, RxDB, Hasura. I'll quickly go through them first, just in case anybody is not aware about them. So what is an offline first app? So an offline first app basically means that the very core functionality of the application does not care about the internet connection. This means that whether the user is connected to the internet or not, the user facing core functionality will work consistently across. So sorry. So the way architecture is that the application which talks to an offline database and only the offline database, and then there is a sync process in the background which keeps the offline database in sync with the cloud database. When it comes to the offline database, we looked at different databases, and we thought RxDB is a very good fit for this kind of use case because it is a reactive database. So RxDB itself is a short form for reactive database. By reactive, it means that you can subscribe to changes that happen in the database, and which is like very important because it's 2020 and everybody wants real-time applications. So RxDB also comes in with a lot of extensions and plugins, and it is community maintained. It is open source. So if you need something, you can always open an issue, talk to the maintainers. And we have actually been doing this quite actively these days. We've been talking to the maintainers about what could be better in RxDB, and we have also submitted some pull requests. So RxDB is basically a NoSQL database, which is reactive. About Hasura, as I said before, disclaimer, I work at Hasura. So Hasura is an open source engine that connects to different databases and different microservices and provides a unified GraphQL backend. So Hasura connects to different REST APIs, different GraphQL servers, different databases, and then it just provides a unified GraphQL layer for your client to query with access control. So of other things that Hasura does, we'll focus only on the database CRUD part for this talk. So Hasura natively supports Postgres, which means that if you connect Hasura to Postgres, you can directly start consuming the data in Postgres over real-time GraphQL. Everything is automatic. The GraphQL schema is inferred from the Postgres schema. This means if you have a table in Postgres, Hasura looks at the table and generates some root fields in your GraphQL schema. For example, if you have a profile table, a profile query would look something like you make a query and you ask for the fields of the profile table. The fields usually map to the columns. So when the client makes a query, Hasura compiles it to a performant SQL query and returns the response to the client. So that is Hasura's real-time CRUD over Postgres. Now that we have a stack set, this is how the architecture looks like. There is a React application which talks to RxDB and only RxDB. And then we have Postgres in the cloud, which is the real source of truth, which is where the state really lives. And then there is a sync happening through GraphQL, which is done through Hasura because Hasura allows GraphQL over Postgres. About the sync itself, RxDB comes with an inbuilt syncing plugin for GraphQL data sources. So you just have to provide a pull query and a push query, and RxDB takes care of keeping the remote data in sync with the local data. So as we were exploring the architecture, we thought of building a Trello clone. Trello is a good use case to try out offline applications, because in an app like Trello, a lot of things are happening on the front end. More things are happening on the front end than on the back end, and the front end is so complicated that it has to be an offline first database. You cannot wait for requests to happen, and it will just be a very bad experience unless you are implementing optimistic UI or something which has pros and cons of its own. So for the Trello clone, firstly, the first question is, what would the schema look like? Would it be SQL? Would it be NoSQL? Because we all know Postgres is an SQL database and RxDB is a NoSQL database. Then the data would be normalized or denormalized. So these are the questions that these are things that you need to keep in mind while you are modeling your data, because the data is going to go into both SQL and NoSQL database. So for Trello clone, this is what we came up with. Just quickly zoom. So on the Postgres side of things, we have a task table which has these fields. We have user table and we have a column table. And in the task table, we have user ID and column ID, which refer to the user and column tables respectively. And then we also have a column rank field, which maintains the rank of the task in that particular column. And now, if you look at the RxDB schema, so in RxDB, we have just modeled the task table, because for an app like Trello, task is the core functionality of the application. That is the most frequently changed data, and that is the data that the user will deal with in the offline mode. Right? If your app requires multiple tables, the functionality involves multiple tables, then you will have to map multiple tables into RxDB. Just a second. Yeah. So now when we go about building Trello clone, the basic things to keep in mind are, firstly, you have to make sure that the assets are available offline, because it is an offline app. The assets have to be available offline. Secondly, you then start building an offline only app that talks to RxDB and RxDB alone, doesn't care about auth, doesn't care about Postgres, so that the core functionality is working and good to go, right? Next, you add, rather than add, next you integrate authorization in your application. You have some auth service, you have some tokens going around here and there. You do that for user and identity management. And finally, you set up the sync process between RxDB and Postgres. So this is roughly the steps that we took while going about building the Trello clone. Another thing we need to keep in mind is that we need to have proper authorization for Postgres itself. Okay, so Modeep, tell me.
Sorry, it was a mistake.
Oh, sure. Okay. So yeah, so we have to authorize Postgres as well. Some basic authorization that we'll think about for this app is, firstly, everybody should be authorized to CRUD data. Like unauthorized users should not be allowed to touch the database at all. Next, the user should not be allowed to forge their identity. That is, they should not be able to do things as somebody else. And finally, users must not be allowed to do unwanted CRUD. That is, they shouldn't change fields in certain tables that you don't want them to change. Like, for example, the created ad of a task, that is a permanent thing that should not be allowed to change. So these kind of, we should restrict CRUD, we should restrict forging of identities, and overall common authorization of the database. So this is very painful, but luckily we are using Hasura, which comes in with its own access control layer. How it works is, your auth service provides a token to your application, and your application includes that token in every query that it makes to Hasura. And Hasura resolves that token into certain session variables, and based on those session variables, access is restricted or granted to that particular user. If you look at it if you look at an example, if you have, for example, a profile table, you can set a rule such that user ID is equal to X Hasura user ID. This means if a user makes a query and the user has X Hasura user ID equal to 3, then that user will be allowed access to only the rows which have user ID equal to 3. So this is like a very simple implementation, but you can build really complex granular access control rules using as a function of different session variables. You could even have 20 session variables here. So you can build really complex rules for securing your data. Cool. So another important aspect is that you have to make your assets available offline, because it is an offline app. The assets have to be available offline. So the most go-to solution is using service workers to cache the assets in the browser itself. If you're using Create React app, it comes with a pre-built configuration for service workers. You just go to the serviceworkers.js file and you uncomment this line, service worker.register, and that's it. Your assets will be cached offline. Next is how do you subscribe to the data from RxDB, right? So we all know as we use React, a React component is a function of state and props, right? And whenever the state and props change, a render is triggered, and then some comparisons happen, and then it is committed to the DOM. That's the basic life cycle of React. So since RxDB is a reactive database, we can make React subscribe to the changes in RxDB. So at the root of your application, you'll simply make a query to RxDB, which returns an observable, and then you subscribe to that particular observable. And whenever a change happens, you set the new changes in the React state. So and the state can be propagated in the child application, and the UI can be rendered accordingly. So another thing to note is that now since the UI is subscribed to RxDB, you don't ever have to worry about setting the React state. If you just change the state of RxDB, the state will automatically get updated because you are subscribed to it. So the set task is used just here. It will not be used anywhere in the rest of the application. So we'll only worry about changing, like mutating things in RxDB, and that will be reflected in the UI because the database is reactive. So for doing CRUD with RxDB, it's quite straightforward. Like you can check the docs, but I've just put some snippets from my code base. This is insert, this is update, and this is delete. So for delete, we implemented soft delete, which means that even when you delete the task, it will still be there, just that it will be marked as deleted. If you want to make it hard deletes, this update will change to remove. That's it. Another thing is the important states to maintain. It's here I bring this up because everybody likes to maintain their own states as per their own preferences, and everybody wants to do things their own way. But I bring this up because in my experience, these three states are what define the flow of your application, right? The entire flow of your application depends only, like mostly, on whether the user is logged in or not, what are the session headers of the user, and whether the user is connected to the internet or not. If you look at the flow of the application, this is how it goes. The app first mounts, then you check if the user is online or offline. If the user is online, you check if the user is authorized using the session headers. If the user is not authorized, you clear the offline database and show a login screen. If the user is authorized, you render the data from RxDB and start the sync of RxDB and Postgres. So far so good. Then imagine the user goes offline. Once the user goes offline, nothing changes for the user. Everything continues to, maybe you can just show a banner on top saying you're in offline mode or something like that. But everything else continues to work the way it was working. Then when the user comes back online, that's when you check. That's when you again check whether the session is still valid. If the session is valid, you do the same thing. You render the app using the RxDB data and sync the changes that were made in offline mode with the server. If the session is not valid, you throw away those changes and again show a login screen. So this is roughly the flow of any offline first application. There will of course be different ways people look at it at, but this is vaguely it in my opinion. You'll have more extensions of it, like you might want to do something different on the first mount, or you might have a better algorithm to figure out if the user is user is authorized or not, or when you should throw away the offline changes and so on. So that you can that will change from different use case to different use case, but vaguely it would look like this is what I think. Another important process is the sync. So as I said before, RxDB comes in with an inbuilt syncing system for GraphQL. So it simply takes a push query builder and a pull query builder, and you have to pass these. You basically have to pass a push query and a pull query. So what a push query means is you push the changes happen on RxDB to the remote server, and the pull query should get the newer changes that have happened in the remote database. And then there are some other configuration options that you can set. So in this application, the pull query looks like this. It sort of looks complicated, but it is like quite simple. It basically means that RxDB is asking for all the tasks which have been updated later than the newest task that it has locally. I'll just repeat that. RxDB asks for all the tasks that were updated after the newest local task was updated. If that doesn't make sense, let me know in the chat. So that's how the pull query looks like. And once you pull this data, it will be synced and merged by RxDB itself. Similar for push query, how RxDB takes care of pushing the task is whatever the tasks have been updated, it tries to push it to the database using an upsert mutation, which is an insert mutation with an on conflict clause, which means it tries to insert those tasks in the database. And if the task already exists, that is the primary key of that task is already present in the database, then it will just update certain fields and not insert it. So that's the push query. And in some cases, you will need to force pull and force push. That is, you ideally want your both your local database and the remote database to be as fresh as possible, right? So sometimes you want to force pull. This is ideal when some change has happened in the remote database. So if the client gets to know if a change has happened in the remote database, then the client should ideally take a pull. So to do that, Hasura also has subscriptions on table changes. So if something our client can be subscribed to Postgres, the task table from Postgres, and if something changes, we can take a pull. And similarly for push, we want to keep the remote database fresh. So whenever something changes in RxDB, a force push should happen. Apart from force push and force pull, there is a fixed interval at which the syncing does not happen. But force pull and force push happen only at special occasions. Force push we don't have to really worry about because RxDB takes care about it. So that is roughly it about the architecture. There are certain limitations since it is a new paradigm, and there are no standard solutions to these limitations. But we have been going around trying to find solutions lately. So firstly, it's compaction. By compaction, it means usually NoSQL database tend to keep revisions of the documents even though they have changed. So RxDB maintains some 1,000 revisions of documents. So this might cause a problem eventually when the data starts getting too large, and you might run into space problems. So you might want to just clear the database, that is to completely destroy the database once in a while and sync it back from the server from scratch. Then there's conflict resolution. Say two different clients update something at exactly the same point. Like what should the database choose? Which change should be committed and which change should not be committed. So usually you can just show a UI saying this has also been updated somewhere else. Which change do you want to keep or something like that. And there are sync errors that when you're trying to sync data between local and remote database, if there are errors, what feedback do we show to the user? I personally don't do anything. I ask the user to chill. Don't worry about it. Just work on your offline app, and sync will happen when it happens. But that might also not be the best case in a lot of cases because you want the sync to happen and you want to provide some feedback if the sync is failing for some reason. And finally, in case of complex schemas, say if you are having 10 different tables in Postgres and you have modeled those 10 different tables onto RxDB, and those 10 tables are interreferenced. So while you're updating some certain fields, you might eventually end up in an inconsistent state. It is just like quite a rare edge case if you model your data well, but it can still happen, and one needs to be wary about it. About more reading, I'm going to share these slides so you can have access to these blog posts. So this talk is mainly inspired from this blog post. And also we have one more blog post about a design guide to offline apps. And there are some more very interesting blogs which you would like to read if you are interested in the offline first architecture. The Trello prototype that I'm talking about, that is committed to this Git repo. You can just clone the repo, deploy Hasura, apply the migrations, and run the app. It'll all work. Cool, that's it. Thanks a lot. And if you have any questions, I'll be happy to answer them.